Welcome back. The objectives of this video is to get some more practice doing residual plots based on a table of data. So in example 4, it says enter the data in two lists on your graphing calculator. Show by linear regression that the best fitting linear function is y hat equals 1.52x plus 2.35. So you'll have to make a list 1 for all the x values and a list 2 for all the y values, and then go ahead and do a linear regression, and you'll see that linear regression is 1.52x plus 2.35. So the table asks us to do the regression points given this equation. So we'll input our x's of 4 and 7 and 10 and see what our y hat tells us the output is. And we can see here that when we input 4, we are going to output 8.42. And when we input 7, we're going to output 12.97. So we're getting all these new points based on our regression line, our line of best fit. So we finished putting in all those x values and come up with our new y values based on our y hat, or our predicted y values, which would be different than the data. So then now that we have data that's different from our, now that we have y values that are different from our actual data, we can calculate our residual points. So our residual points, we're just going to subtract our y hat y's from our actual data and come up with our residual points. So all the x values on our residual points are going to stay the same, and then our y values will be like 9 minus 8.42 and 14 minus 12.97 and 18 minus 17.52. So those are the error, if you will. They're not really errors, but they're residual distance in our y's, and we'll have to see what kind of pattern that provides for us. So by subtracting y hat from y, the y values in the center, from the data point actual y, we come up with our residual points and those residual values. So it says make a residual plot on your calculator, and how well does the linear function fit the data? Well, since our y's are pretty random, I went to my calculator and I got a residual plot, and I had, some plots that were above and some plots that were below, but there was no particular pattern to those. So our data, our y hat, actually is a pretty good predictor of the data. I would say that the linear function fits the data well because the residual plot is random. Y hat fits the function very well since the residuals are distributed along y equals 0. I didn't really answer question C, find the residual points using L3 to complete the final column. I just did the math for that, but we'll do this in the next sample problem, and I'll show you how to do that in this next one. In example 5, we can see the table gives the wavelength x in meters and the wave speed y in meters per second of deep ocean waves. Explain why a quadratic function would be expected to fit the data well. So let's go ahead and put this data into our calculator, into L1 and L2, steal our x's from L1 and our y's from L2, and take a look at that data. So into stat, edit, looking at my lists here, if I go over to list 1 and 2, I've put the data in lists 1 and 2. So go to second stat plot, I'll turn plot 1 on. We're going to draw from L1 and L2. My window is set between x's go from -2 to 15. My y's do not, so I will correct those, and I'll do my y's from -2 to about 80, and I'll count by tens. And we'll go ahead and graph our scatter plot. So it appears that a quadratic model would fit this. Linear might, but you can see the curve here. So I would say, since it's increasing and concave up, I would go with a quadratic model here. So we're increasing and concave up. Find a quadratic regression equation. So back to our calculator, into the stat menu, calc. We're going to do 5, a quadratic regression. We're going to draw from list 1 and list 2. And let's go ahead and store that in y1. And we'll calculate our quadratic regression. So our coefficient on x squared is 7.747. Our coefficient on x is -1.23075. And our constant is 3.04. And that's in our y equals. And we graph that. And wow, look at that. Our trend line goes right through those data points. So I suspect that we will have, when we graph our residual values, they're going to be really close to the y=0 line. So let's go ahead and graph our residuals. We'll go into the stat plot menu. I'm going to turn plot 1 off, and I'll turn plot 2 on, and that one's already set up to do a residual, but a quick review. Oh, I don't want to draw from L1 and L2, or L1 and L1, so yours might be L1 and L2, but I want to change that to residual. So we'll go into the stat menu again, but the list, so second stat, and we want that to be the residual. And now we're going to plot that. Now we do have to adjust our window. Our x's will go from -2 to 15, that's okay. But our y's, we think this is going to be pretty close to y=0. So I'm going to make that 2. I'm going to go to the y equals. I don't want to graph my original function, and just for fun we'll graph y=0 in red and take a look at that, and I think I forgot to turn on plot 2. So let's turn on plot 2. And we can see our residuals are really close to that line. Our window, I forgot to change my scale to 1, and now you can see that this is like, 3/10 below and less than 1 above. So this is a really good regression. Now I did promise you that we could find these residual points. We could find out exactly what the x's and y's are. We can see this is an x of 3. But if we do the trace and just hit trace, at x=3, we get our y. So these are our residual values. And I continue to plot, just go along the scatter plot here. When x=5, there's my residual value. And just keep cursoring along. When x is 7, and cursor using the trace. So we're just tracing along our scatter plot and getting those particular points. So answering question C, I would say yes, the residuals are closely aligned with the y=0 line, and there is no pattern in the residuals. So this is a really good model for the data. In example 6, we're told that the number of views for a popular podcast is increasing. maybe it's Raph and the Meatballs. The table shows the estimates of the total views each month since January 2010. That would have to be like January of 2024 probably. But anyway, we're going to do this from 2010. So that gives us the months since 2010, and the total views in millions of our podcast. We'll put our data into L3 and L4, so X is in L3 and Y is in L4, and then we'll find a quadratic, exponential, and power model. So I head to my calculator, stat, edit. I edit L3 and L4, so those are the two data columns I'm going to use. I set my window based on the data, and I'll turn on look at plot 1. I'll turn that on, and now I'm going to draw from L3 and L4. And there is my scatter plot of data. So it doesn't look like linear is going to fit this very well. Exponential might work well. Quadratic might work well. So let's see what works well. So let's go ahead and start, and we'll go into back to our stat menu, calc, and the first one is a quadratic model, so option 5. We're going to do L3 and L4. And store our equation in Y2. And that looks better. So I have my A value, my B value, and my C value. And we can go ahead and graph that. And that appears to fit our data pretty well. Let's go back and do it again. So, stat, calc, and now we want to do an exponential model. Which was 0, and looks like A is going to be our power model for the next one. So exponential model, L3 and L4, and I'm going to save that in Y3. And calculate. So my A value is 0.2386, and my B value is 1.1. And we can go ahead and graph that guy right at the same time. That's the black one. Looks like the red one's probably a little bit better than the black one, but we'll have to see what our residual plots tell us. And let's go back and graph our power model. Stat, calc, and we said that was a power regression, L3 and L4, and I'm going to store that in Y4. Second F4, option 4, and we'll calculate that. And that one's correct. Our A value is 0.1156 or 1155. And our B value of 1.1548. And that one is stored in Y4, and now we can graph that. So all three of them are being graphed, and wow, it doesn't look like the power model is a good model at all for our data. So it says in B, so in question B, it says use the residual plot for each regression model. So this is my residual plot for the power regression. It appears to be concave up and increasing behavior. There appears to be a pattern here. So I would say that the power model is not a good model to fit this data. Using the exponential function, I go into my plots, and let's take a look at plot 2. And I'm going to draw from L3, and I'm going to do my residual list, and we will go ahead and graph. And that does somewhat seem to be randomly scattered but decreasing, but it looks like pretty good data there. So then doing my quadratic regression again, I'll store my quadratic equation differently. I'll go into vars and y vars and a function. We'll store it as y1, and we'll calculate our regression, and there's our quadratic regression. And going into our plots, second stat plot, we'll use plot 2, and we'll turn that on. We'll use L3, and our Y list will be our residual. If you don't remember how to do that, you go into the second stat menu and the bottom option there, 7, and enter and graph. Now I did graph my original function there by accident. We'll get that out of there. Graph. And that looks really good. Our residuals are scattered randomly, and I would say that the quadratic model, as what we thought, is the best model. And the final question says, using the model chosen, what is the expected number of views in 5 years? We're going to make that 60 months because our table's in months. They're getting sneaky with us. And we'll go to our calculator and have it find that information out for us. So if I want to find 60 months, I got to make sure that my window is big enough. So I got my X's are going out to 75. I'm going to make a guesstimate. I'm going to make sure my Y's go enough to 50, which would be 50 million. I'll count by 5, so at least it's in my window. And I have my plots on, so I'm plotting my original data and my function. I'll graph that guy, and now we'll look to see where we're going to be in 60 months. So second calc, find a value at x equals 60, and at 60 we'll have about 35.5 million listeners to our podcast. And that wraps up this edition of Residual Plots, and you'll get some more practice with this when I see you in class.